In this problem, we're given a formula that describes the motion, specifically the velocity or speed of a particular object as a function of time. So for part A, we already know what the object happens to be. It's some kid's toy, and we know that we can describe its velocity at any given time with the formula given. So part A asks us for what V is when the time is 1.4 seconds. So we literally just need to go through and plug that in. So if I go through and plug these numbers into my calculator, I'll find that the answer ends up being negative 1.6 meters per second. Now, for part B, it's asking for the acceleration of the toy at that same time. So in order to take my velocity and turn it into an acceleration, I need to remember how they're connected. Specifically, the acceleration is the derivative of velocity with respect to time. So I need to take the derivative of this full formula that I have. I'm going to temporarily leave off the units. So that'll give me 2 times 0.6 times t minus 2, or 1.2t minus 2. Now, if I want to go through and figure out what the acceleration is at time 1.4 seconds, then I simply plug that in. And I find the answer is going to be negative 0.32 meters per second squared. Now, in the final part of this problem, we want to find the position of the toy at that same time, 1.4 seconds. So I remember that acceleration is the derivative of velocity with respect to time. So now I need to remember how velocity and position relate to each other. So I can either remember that velocity is the derivative of position, and I'm going to use x here just to pick a dimension with respect to time, or I can go through and invert this and I'll have an integral. So that means that I need to go through and integrate my velocity function. And there are two ways that I can go through and do this. I can go through and do this as an indefinite integral without any limits on my integral. And if I do that, I need to account for the unknown constant. Or I can choose to go through and integrate this with limits because I already know something about the starting position that I was given and the time at which I'm trying to figure out what's going on. So either are reasonable ways to go through and do this. I'm going to focus on the indefinite integral version, because this is something that I know will always work. So I'm going to do this with the indefinite integral. So I'm going to do this a bit piecemeal so I can show you my thought process when I go through and do any integral, and then we'll put it all together at the end. So if I want to integrate 0.6 times t squared, then I know that my t squared is going to turn into t cubed, and that constant will still be there as well. So I could stop here and go through and see if that's correct. And the way to go through and do that is to take a derivative of what you came up with. And that's a good way to go through and check to make sure you've got things right. So if I did that, I would get 0.6 t squared, but that I would also have this 3 up front, which is not what I started with. So that means that the result of my integral up here actually needed to be divided by 3. Because if I had that, then I would see that they would cancel, and now my answers actually go through and match. So I always go through and check myself when I'm doing these. So with that in mind, we'll go back to our full integral. of which we've already solved one piece of it. So we know this is going to be 0.6 t cubed over 3. And in the same vein, I know that my t will go to a t squared. And if I mentally think back, the derivative of t squared is 2t. That's exactly what I had when I started with, so that's great. And then lastly, there's going to be some sort of constant out here, some unknown constant. Now, the way that we go through and figure out that constant is we use some information that we already had. So for example, we already know from the problem that at t equals 0, this position happens to be 3 meters. So that means I can go through, plug in 0 for all of my t's here. 0 cubed is 0. 0 squared is 0 plus c. I know that this equals 3 meters, so my constant must be 3 meters. So that means my equation that describes the position as a function of time looks like this. So to answer the final part C, I need to now plug in the time of 1.4 seconds. So if you go through, plug all of that into your calculator, and you'll find the answer is 1.5 meters.